Okay, it's 4 o'clock, so let's go ahead and get started today. All right, afternoon, everybody. How's everyone doing today? Virtual showcases tomorrow, so I'm sure a lot of you guys are working on that or stressing about that, I'm sure. Yeah, so yeah. So today, what I wanted to do is I just wanted to do just a quick kind of demonstration. So I plan to end maybe after 20-30 minutes because I know a lot of you guys are preparing for the virtual showcase. So I want to let you guys get back to it. Okay. So it's not anything that's this on kind of the scale of relative important stuff in Ansys. This is, I think, for a lot of you guys kind of relatively low. I know a few people might be interested in doing fatigue analysis, but I think a lot of you guys are kind of already set in what you want to do. So this is kind of just for your information to know that Ansys has this capability, and then we'll probably call it pretty early today. Okay. Okay, so a couple, I think one announcement before weekend, because I think we talked about SOQs on Tuesday already. So please remember to do that if you haven't done that already. And then the other announcement I want to make is that on next Wednesday at 5:30, what I'm going to be doing is I'm going to be giving a presentation on some of the research that I've done in the past on finite element simulations of blood flow. So if you're interested in learning about that, I'll post the link to the Zoom call on our class page on Titanium. So of course, totally optional, but that's just, for your own interest, if you were interested in knowing. So I invited all my classes to it. So hopefully, there's a good crowd, but absolutely, it's not required because I know it's not during our normal class time. So if you have other class or not, then just drop by if you're interested. Okay. Okay. So are there any questions about anything before we get started today? Okay. So let's go. Oh, question. So the question is recapping how the final presentation will work. So the final presentation will not work. So we're not going to be doing any final presentations. So kind of right after spring break, we all voted to do just additional Ansys stuff instead of doing a final presentation. So the only thing you guys have left to turn in, I guess you still have to turn in Ansys Activity 6. So that's due next Thursday. And then besides that, there's just going to be the final report. And the final report's going to be due on Tuesday, May 19th. Yes. Yeah, so the final report's due Tuesday, May 19th. But so, but I did want you guys to just make just a short PowerPoint slide. So you're not going to be presenting it. But what I'll do is on the same day on May 19th, I'll have you guys submit just, maybe like 5 PowerPoint slides. I'll make a template for you guys just so you know what to fill in. And then you just turn in the slides, and then what I'll do is I'll put that onto a Dropbox folder, and I'll make that available to the class, so you can check out what other people worked on for their projects. All right, sound good? Cool. All right, so let me share my screen. Okay. Oh, that's Reddit. We don't want that. Okay. So this handout is on Titanium. So it's just a short handout, so it's just 9 pages. So what I'll do is there's just kind of a quick just intro blurb about what fatigue analysis is, although I think mostly everyone is pretty familiar with it. And then from there I'll just go through a demonstration. So I have an Ansys project that's already kind of filled out. So we're not going to go through all the usual steps. I'll just kind of highlight to you guys just the important steps, just so we can end a bit early, so you guys can get back to preparing for tomorrow. Okay. Okay. So the topic for today is fatigue analysis in Ansys, right? So usually when we do a static structural analysis in Ansys, most of the times we're interested in seeing, whether our part will yield or structurally fail. Okay. So we've done this in static structural, and what we've done usually is we've used Ansys to compute the stresses inside our geometries, and see if those exceed the yield strength or the ultimate yield strength of the material. But what we haven't really been talking about is that this kind of analysis is you know, it's a test to see, like, you know, if you take your part and you load it for the very first time, and you kind of ask, like, will that break or not? Right? So this is kind of like we're testing basically for catastrophic failure. If you know, first time you put it in motion and then it fails. But a lot of times, you know, a lot of engineering structures don't fail the first time that you load it, because over time, you know, as you use a member and you load it and you unload it and you do this over and over again, the material starts to fatigue, and then as it fatigues, the material gets weaker, and then you're subject to failure, maybe, you know, 3 years, 4 years, 5 years, 10 years down the line, right? So this concept is fatigue. So a lot of you guys are familiar with it. And so the nice thing is that Ansys actually has a way to actually model fatigue and give you some answers for fatigue. It'll tell you things like how many loading cycles that this part can withstand before it ultimately breaks, and it can also tell you a factor of safety. Okay? And so the tool that we're going to use in Ansys to do this is called the fatigue tool. So it's very aptly named, right? And it's nice because it's just an extension off of a static structural simulation. So if you have a project already for your final project, say you've already done a static structural, you can just add the fatigue tool to it, and there's really, you know, nothing else you really have to change. This kind of just goes on top of everything else. Okay. So the only caveat is that you have to have a material that supports this fatigue analysis. So in particular, for your material, you need to have what's called the SN curve defined. So that's the stress versus the number of loading cycles. That's what SN means. So if you're using some of the default materials in Ansys, like structural steel, and I've tested it for aluminum alloy, the one that's already built in, so that has it already. But if you're using a material that's outside of Ansys, you need to do quite a bit of data entry in order to get it to work. Okay. So in this, basically, there's just a short handout and demonstration. I'm going to be using structural steel just because it has all of the properties laid out. But I'll show you kind of where you can check that. Okay. Okay. Any questions on this before we jump into Ansys? Okay. So here we are in Ansys. So this is an example project that I've made. I can probably upload this too, so I'll upload this, because what I did basically was I just took kind of a thick version of our first Ansys activity for a plate with a hole, and I'm doing a fatigue analysis on it. So our first stop is actually going to be engineering data. So let's go ahead and double click that. And remember, this is where we define all of our material properties. Okay? So you can see for this project, I have two materials right now. So I have structural steel, which is the default material in Ansys. Okay? And you can see a lot of this information is already kind of filled out for you. Okay? So we have things like the Young's modulus, the Poisson's ratio, and then that fills in your bulk modulus and your shear modulus, respectively. Okay? But for the fatigue analysis, I want to draw your attention to a new entry here that we haven't seen before, and that's called the SN curve. So if you're working with a Ansys standard material like structural steel or aluminum alloy, then some of them come with this. So you can just left click this, and you can see the information here on the right. And let me move this guy a little bit just so you can see. Okay. So like we mentioned, the SN curve stands for the stress and the number of cycles. Okay? And basically what this curve is defining is it defines the kind of the decrease or the decay of the yield strength of material as you load it for a certain amount of cycles. Okay? And so in this case, you have the x-axis here is the number of cycles, and then the y-axis here is the stress. Okay? And it's defined as alternating stress because that's the stress that kind of is you load it and then you unload it. So it's a cyclic kind of stress. Okay? And you can see that it's defined by this, right? So this is already done for you, so you don't have to add that. And then we can check for aluminum alloy. So this is the aluminum alloy that you get from the engineering data sources. So you can see it also has an SN curve that's given by this. Right? So I think a lot of the times these curves, they're experimentally determined. So you can, people have run experiments on these kinds of materials, and they've, found that these are the SN curves. So let's see. So if you want to add more materials, you can go back to engineering data sources right here. Okay? So that's in the same place as it was before. And then we can add materials. So to get aluminum alloy, what I did was I went to general materials right here. And then I searched for aluminum alloy, which is right here. and then I click this add button. So this was already added here, so that's already there. But let's check concrete and see if that's there. Okay. So I've added concrete to our project by clicking this this plus button. So now we can go back here. Okay. And you can see for concrete, there's and you look in the bottom here, there's no SN curve. Right? So not all the materials in Ansys are going to have that SN curve for you. So for those ones that don't, you need to add it yourself. Okay? So if you don't see SN curve right here, what you need to do is you need to go to the left-hand side of the toolbox here, and you can see right here we have a SN curve, right, under the life parameters. So let's go ahead and double-click that, and then once you double-click that, then you can see you've added SN curve to this the SN curve property to this concrete. Okay. But then when you left-click it, you can see on the right-hand side here, all the data here is empty. So because it wasn't previously defined, you know, it doesn't have anything there. And so what you need to do, if you want to perform a fatigue analysis with concrete, you would need to look up online and see, you know, what is the SN curve that you can use for concrete. So I don't have this off the top of my head, but I can just show you how to enter things into this table. So it works basically just like Microsoft Excel. So you would type in a number, and then you would type in the stress. So let's say this is 1e to the 10, okay? And then you would keep adding more here. Okay. So I'm just adding in random numbers right now. Right. Okay. And so if you can find this SN data online, then you can basically input it manually so you can perform a fatigue analysis on this material. Okay. Right. And I'm not sure if you import a material from SolidWorks, they might have this data already for you. So that might be something that you might check if you want to do this for your project. And say you've already CAD'd up in SolidWorks, if you import the material, it might have this information for you. But I've just never tried that before. But you know, you would kind of hope that SolidWorks might have this because it makes things really convenient. Because finding this information online is pretty difficult. So for this activity, I tried to look up some of these SN curves, but I wasn't that successful. So I found a lot of plots, but plots aren't really that useful because you can't really read the numbers off them that well. So getting the actual data might prove to be a bit more challenging. Okay. All right, are there any questions on this? Let me delete this comment. Question? Do you have a question, Sergio? Is that no? So this is just a informational handout. So the activity was totally done from the last lecture. So this is kind of just for your information on how to do fatigue analysis. So it's nothing to turn in, but it's just, you know, something if you're interested in doing an Ansys, this is just kind of something I put together just to show you, you know, where the buttons are basically. Mm-hmm. All right. Any more questions on this? Okay. So then let's exit out of here since we have the materials that we want. And I've already prepared the geometry just for the sake of brevity. And then let's double click model. And then let's open this up in mechanical, which I already did. Okay. So I watch a lot of cooking shows on YouTube just because I enjoy cooking. So I feel like one of those people on the YouTube cooking shows where they show you how to prepare something. They tell you to marinate it for 1 hour, but then they have one that's already magically prepared for you. So that's what this kind of is right now. Okay, so here we are in static structural. So we've seen this probably a bajillion times this semester. So you know, a lot of this, you know, we don't have to do. But you can see here I've already meshed the material. Right? It will be. So the question is this project on titanium? I don't think I've uploaded it yet, but I will right after this. Yeah, so I'll upload the whole project just so you can see basically the kind of from start to finish. Yeah. So our first step, our first step in Ansys Mechanical is always the mesh. So in here, I've already prepared the mesh for you, so that's good. Okay. Next, we have to apply a boundary condition. So just like we did in Ansys Activity 1, I've applied a fixed support on the right-hand side, and then I've supplied a tensile force on the right. Okay. So we have a bar with a hole, and then somehow we've fixed it we've glued it to a wall, and then we're pulling it on the other side. Okay. And then for the outputs, I've defined the total deformation and the stress. Okay, so all that is pretty standard. We've done that a lot before. So the thing that we need that's new is going to be this fatigue tool. So actually, let me delete this just so you guys can see it being made from scratch. Okay. So to open up the fatigue tool, remember you don't have to change anything in your static structural. You basically just define everything as you normally do. We're just going to add to this. So let's right-click on Solution A6, and then let's go to Insert. And then from Insert, we go down to this button down here known as Fatigue. We'll click that, and you can see we've defined our fatigue tool. Okay. All right. And you can see once we've included this fatigue tool, then we have this new menu down here on the left. Okay? And you can see obviously our 3D window changed over here too. Okay. So there's a few settings that we have to change here. So the first type is the type of the loading. So we have, there's several options here. So the first option that you see right here is fully reversed. And so what that means is that it's going to take all the loads in your model and then it's going to fully reverse them. So you can see you have a sinusoid wave here. So it's going to start up at 1 right here. So when the load is 1 right here, it's going to apply the loads basically exactly as it is in the model. But then as it goes down right here, you can see we're in the trough of the sine wave. Down here, what it's going to do is going to reverse all of the loads. So in this case, since we have a tensile force, when it's that load is reversed, that means it's going to go back. It's going to go into a compressive force. So then it's going to basically repeat this cycle of tensile, compressive, basically with the exact same magnitude, or at least it's assumed to be. Okay? And then each kind of cycle of like tensile and then compressive, that constitutes one loading cycle. So that's fully reversed mode. So that's one way that you can do it. But a lot of times, you know, your part is not going to be, the load is not going to be completely reversed. So I think it's actually like that just to just for computational convenience. So the other type that you can do is called zero base. So you can go down here to the left and then change the type to zero base instead of fully loaded or fully reversed. And what this does is that instead of going to the full complete opposite load, what it does is that it goes from the fully loaded scenario, what you had here, down to 0. So 0 basically means that it's totally unloaded. So it's going to load it and then relax it and then load it and then relax it. And each cycle of one of these counts as one loading cycle. Okay. All right. Okay. So then the other thing that you have to select is you have to select a mean stress theory. Oh, question? Oh, history based. Yeah, so you know, this is that I think a history based, I haven't experimented with it, but I think with that you can kind of input your own kind of loading based cycle, because you know, even though these curves here, they're two different options for cyclic loading. You know, a lot of times the loading that you experience in a model is a lot more complex than this, especially, you know, something that's used for practical purposes. So I think for history history data, what you can do is you can probably manually input your own your own time wave for the loading. Yeah, that's my guess for that. But I haven't tried it out yet, but that's kind of what it sounds like to me. Okay, so where were we? Oh yeah. So then the other thing you have to input here is a mean stress theory. Okay? So I'll admit that I'm not a structures guy. So all of these names mean nothing to me. So these are just 3 dudes' names that probably contributed a lot to structural mechanics. But I barely know the history of my own field, so I definitely don't know the history of other fields. So, you know, but basically what these represent are different, you know, ways for different ways to achieve fatigue failure in your model. Okay. So I'm hoping that you guys are more familiar with these models than I am, so you can probably pick these more intelligently. But just from this model, or just from this graph here, it looks like the Goodman model will basically be a mean stress theory for ultimate failure, and then Soderberg will go up to yield. So then you can see it takes a lot less stress in order to yield a part rather than its ultimate failure. So that can be something that you use to choose this. But in this case, let's go all the way up to ultimate failure. So let's choose a Goodman. Okay. Right. And then from here, we can choose some additional outputs that we can do. So let's choose life. Okay. So the life output, what that's going to do is it's going to show you a color contour, and then from that color contour, you can see how many cycles that this part that certain areas of the part can undergo before it fails. Okay. And then let's also include safety factor. Okay. And that's pretty self-explanatory. And so once we've set all that stuff, we can go ahead and hit solve. Okay. And so you can see, actually, let me lower this load. I think in the document, I only had this at 10,000. So you go ahead and click solve, and then while you wait for it to solve, are there any questions I can answer? All right, looks like it's done. Oh. Okay. So normally the life one will show you something interesting, but it's not. So actually, let me change this. Let me change this down to 1,000. Let's see. So ideally, what the life graph should show you is how many loading cycles that your part can withstand before it breaks. Okay. Maybe I need to make this higher. Yeah. Mm-hmm. There we go. Okay. So if you increase the force, so I've increased the force to 100,000. Let's look at this life graph. Okay. So you can see, the kind of the color scheme that Ansys uses is it uses blue for areas that are relatively safe that you don't have to worry about, and it uses the red to indicate places where you should look at this. Okay. So for the life graph, the way that you can read this is that basically the blue areas will tell you regions of the model that can withstand a lot of cycles before breaking. Okay. And then red areas are in danger of fatigue failure before it reaches up to that maximum of 1 e to the 6. Okay. So you can see here we have red areas over here, okay, on the inside here. And then what Ansys is telling us is that if we have the loading as we had here, it can only withstand 27,153 cycles before it's in danger of fatigue failure. Okay, and so where it's going to fail with fatigue first is going to be on these areas right here. Okay, right. So then now you can look at safety factor. So basically, the way this is defined is that it defines areas of the model which are in danger of failing. So you can see here we have a safety factor of only 0.526, right? So that means that these areas are going to fail before they reach their maximum life. Right? Yeah, yeah. So the comment is, yeah, topology optimization would be useful for this. Okay. All right. So the question is, does fatigue tool automatically generate the safety factor? Yes, it does. So I think it has some kind of threshold for what the minimum, kind of the minimum amount of cycles that it wants to have. And then it kind of divides it by that. So this is kind of safety factor based on how many cycles it can withstand. Yeah. Mm-hmm. right, so we can change this. So so that was a zero-based loading. So let's change this to fully reversed. Okay, and let's evaluate the results again. Okay, so you can see if we change the results to fully reversed, we can only withstand 8,537. So if you fully reverse your load, then it can withstand a lot less stress. Okay. All right, so I'm getting an error that it's missing the yield strength. Oh, okay. So you're getting an error where you can't find the yield strength. So yeah, that's going to be an engineering material. So before I go back to the engineering data, are there any questions on this? Yeah, yeah. So the idea is that the red locations are where it's going to fatigue first. Mm-hmm. Yep. All right. So let's go back to engineering data. So let's close this. Okay. So are you using? So Sam, are you doing this for one of the materials in your project? So not structural steel and not aluminum alloy, I'm guessing, right? Okay, so I think you have to add them here. So let's see. It's one of these here. Oh, nice. Yeah, if the oh, I think what you have to do is you have to see on this left here, you see this strength right here. And then what you can do is you can double click this strength parameter. You might need, I don't know if you need all four of these, but you can basically double click these to add them to your material, and then you can input the data for those as you find it as well. Yeah. So if you're missing data for a certain material, then you probably have to create, adding a property kind of is in two steps. So you have to kind of add the field for the property here from the left first, and then you come to the middle here, and then you actually add the data for that. Yeah, yeah. So it's under strength right here. All right. Any more questions on this? All right. So I'll stick around for a while, but that's all I had planned for today, because I know, you know, there's the showcase is tomorrow, so I know, you know, all you guys are really stressed about that. So I wanted to give you guys some more time to work on that. Right? So that's it for today. So on Tuesday, what we're going to do is we're going to do our CFD tutorial. So I just finished that up today. So upload that in Titanium, and then we'll probably spend maybe like 45 minutes, 50 minutes on Tuesday doing that. And then Thursday, we have a guest speaker, which is going to be Dr. Sanders, talking about some of the research that he's done in finite elements. Okay. So, you know, hopefully it's going to be mostly just interesting stuff, you know, for the rest of the semester. Okay. All right. So question, when will the red location fail? Right. So, so, you know, the graph that we did on the life, so the life contour plot will show you how many cycles it will fail at. So that the number on that contour on the color bar will show you the number of cycles where it will fail. Mm-hmm. Yeah. Okay. So that's all I got planned for today. So so have a great weekend, and best of luck tomorrow at the showcase. So I'll be there. So I signed up for tracks 1, 3, and 4. So I'm looking forward to seeing some of you guys' presentations. Right. So I know it's going to be, you know, I know it's going to be really challenging to do a virtual showcase, but you know, you guys have been working really hard on these senior projects, so you know, you guys should be proud of the work that you did, kind of no matter what happens, right? Okay, so I'll see some of you guys tomorrow at the showcase, and if not, have a great weekend, and I'll see you guys on Tuesday. All right, so Jamal, yes, yeah. So the so when you have a fully reversed load, then it takes less cycles because it's basically doing kind of double the loading. So it's like, because before you're basically loading it and then you're letting it rest, and then you're loading it, you're letting it rest. But for fully reversed, you're loading it in one direction and you're fully loading it in the other direction. So it's kind of you're kind of stressing material kind of twice as much. Although the effect is more than that because you're kind of going up and then back. No, yeah. So there's nothing to turn. There's nothing to turn in for this. This was just for you. This is for just for your guys' just for your guys' interest. So the only things you have to left to turn in are just Ansys Activity 6 and then the final project. So this was just something that I put together just to kind of help you guys out if you're interested for the final project or if you want to use this in practice. Yeah. Damien, I won't laugh. I promise. Yeah.
Professor, I have a question.
Sure.
Yes, so when it came to, I remember you brought it up at one point. I'm not using my computer for Zoom. I just
Okay.
have it separate. But on the, I believe it was last week when you were bringing up the materials that can be used for like the final project, you brought up wood.
Mm-hmm.
And then like we had to do something specifically different if our part was a wooden body. Can you repeat what that was? Because like I'm looking at the because my project is basically wood for the majority of the part.
Mm-hmm.
And when I go in my simulation, I'm trying to see like the best way I can change the material to get the exact properties of the type of wood that I'm using.